Right, let's take some measurements now, so we can do a calculation to find out the internal resistance of this cell. Okay, right, so first measurement, we need the EMF of the cell. Now remember, to measure the EMF, and just the EMF of the cell, you need to use a voltmeter and you need to measure the terminal PD, the terminal potential difference. This is the important bit, when there's no current flowing through the cell. So if that's the cell connected to the voltmeter, there's no current flowing. So if there's no current flowing, what we're measuring here is the exact EMF, the total energy available to the electrons. So if you want to write that down, 1.47 volts. Right, let's get the cell, let's connect it to the circuit, like so. Now, another thing we need, another piece of information, another measurement, is the current in the circuit. Now I'm going to use, because we've got around about 1.5 volts with a 100 ohm resistor, is going to be a small current. We're looking at a couple of milliamps. So we need a multimeter for this. So I'm going to set that on 200 milliamps and obviously break the circuit and then connect. So there's our current in the circuit. We're looking at 14.4 milliamps of current flowing through the resistor and back to the cell. Okay, final measurement. We need the potential difference or the potential drop across the load, across the external resistor. We do this, we use the same voltmeter and we're just going to go like that. So there we have it. EMF of the cell, if you remember, was 1.47 volts. The potential drop across the external resistor is 1.3 volts. So as we can see, there's some lost volts there. And the current in the circuit is 14.3 milliamps. Right, let's do the calculation.